To start, the purpose of this lab is to show the relationship between kinetic, gravitational, and spring potential energies when a mass is oscillating and attached to a spring. We will see the observed position of a real-life simulation made through Tracker and a predicted position of an online computational model made through GlowScript and based on Tracker's X and Y position values. So, some models and fundamental principles used are first Newton's second law, and it's intrinsic to this lab because an object's change in momentum is proportional to acceleration and inversely proportional to its mass, and F net in here is going to be the spring force plus the force of gravity. Then the energy or gravitational force rather. Then the energy principle is going to show a system's change in energy is equal to the change in energy of its surroundings. So if there is no change in energy in its surroundings, then total energy will be equal to zero. Or change in total energy is equal to zero, and a brief preview of this lab is that each of the potential energy components will add to zero and show a constant change in energy equal to zero, thus proving the energy principle to be true. So here are the different potential energy formulas I used to this lab, and they are intrinsic to this lab because there's a spring involved, there's movement for kinetic potential energy, and gravitational potential energy. It's above sea level, so that's my reasoning on that. And then some assumptions before we even start this lab is that the addition of each of these potential energies will equal zero since there is no work done in the surroundings because of how we set up the system. And the system, that leads me to say that the system is the spring, ball, and the earth together, and the surroundings are a total of nothing. And so the initial conditions are first that the initial velocity is zero since it's dropped from rest, and the position is these values here. Got from Tracker. So the details of the experiment, I first used the recorded video of the oscillating spring, and then I took that video to Tracker where I observed the location of the center of mass at different timestamps to Tracker. Then I used GlowScript to create a computational model of a ball attached to a spring and used potential energy formulas to equal the total change in energy, which is equal to 0 joules. I utilized Google Sheets to insert my Tracker X and Y data, and last, I used this Google Sheets file for the GlowScript model to compare these Tracker values with the computational changes in energy. So what you'll see here is the observed version of the Tracker data, and you can see that the center of mass is tracked in this website, okay, this app. So GlowScript. Here's some lines of code that are pretty important to this lab. First is a spring constant and the relaxed length of a spring. These are important because I calculated these values by first finding the oscillation period, and I used Tracker data to find T1, T2, and T3. And once I did that and I found the oscillation period, I could put that into the oscillation equation. T equals 2 pi times the square root of m over k, but if you square all of that, then you can get k, and so once I found the k spring constant, I could put that into the F net is equal to Fs plus Fg formula, and yes, then that's how I found L naught, the relaxed length of the spring. So each of the potential energy formulas that are important to this lab are in these lines of code starting at 137, and yes, they were important, as well as the velocity of the ball and the position vector there. Okay. There is a change results. There is a change, especially near the end, in the X position values between the computational experimental models, and this is largely due to the outside forces in real life, such as the drag force. And this model shows that the system is not isolated from its surroundings. So very important to this lab. And then some possible sources of error, as you saw in Tracker, there may have been some of the markings that were not completely in the center of mass, and then another human error, it includes when starting the position, because I had to make sure to start tracking the data as soon as the man drops the ball. So the first what does it mean question. What is the energy principle satisfied? Hooray, yes it is! As you can see on the right, the graph shows that each of the changes in potential energy equals 0. So there's no external forces acting on the system. And then the second what does it mean question, the two K spring constants are different depending on the X and Y directions, and this is all because of the oscillation time periods being different depending on your X and Y. So thank you so much for listening.